Let us now see some LTL specification patterns that occur in practice. For example, using LTL, we can say that whenever a process gets started, which we model as it being in a starting state captured by an atom called start, then that process is active, captured by an atom called active. In short, always start implies active. The next is an important pattern for the functionality of a workflow system. Always requests are eventually granted, expressed using the atoms request and grant. Requests can arrive at any moment on a trace, on a sequence, on an execution sequence. The property says that always when they arrive, they will be eventually followed by a grant. Perhaps not immediately, but eventually. That is, after a finite amount of time. In short, always request implies eventually grant. Note again that the parentheses matter. So if we remove the parentheses, we would get something completely different. We would have gotten always request implies eventually grant, which is a quite different property. Okay. The next pattern says that a process is enabled infinitely often. There may be times when it is not enabled, but at any point, if we wait for some time, it will become enabled. This could be about some form of service that becomes available if we are willing to wait long enough. Always eventually enabled. The next pattern is known as strong fairness. Say a process is enabled, which means ready for running infinitely often. Then it will be run infinitely often. In other words, the scheduling will be fair to this process. It will not indefinitely ignore the enabledness of a process, but at some point it will act on it and run this process. In short, always eventually enabled implies always eventually run. Next pattern says, a process will never become permanently inactive. In other words, it is not the case that eventually it will become permanently inactive. Not how permanently is modeled as always, and never is modeled as not eventually. Okay, so we have an always occurs here to capture the notion of permanently inactive. So permanently inactive is this part, and we say that this will never happen. So this is not eventually, which is the same as never. Okay, so far we worked with fairly abstract patterns, but more concrete and more detailed patterns can be considered as well. Here's a more concrete pattern. It is always the case that when a lift is at the second floor, travels upwards, and the fifth floor is requested, it will not change direction until the fifth floor is reached. So if these conditions occur, namely it is at the second floor, it travels upwards, and the fifth floor is requested, then it will not change direction until the fifth floor is reached. How can we express this? Quite simply and elegantly in LTL. We have atoms of the form at x, where x is a number, okay, expressing that the lift is expressing that the lift is currently at floor x. Okay, we also have an atom called upgoing, expressing that the lift currently goes upwards, and the atom pressed x, where x is again a number, expressing that the button at floor x is being pressed to request the lift. With this in place, we can say always at 2 and upgoing and pressed 5 implies upgoing until at 5. Note that will not change direction until at floor 5 really means in our case keep going up until at 5. Has the presence of up going until 5. This really means, okay, keep going up until you reach floor 5. So you can see that a fairly verbose a pattern that is fairly verbose in English can be expressed succinctly and elegantly using LTL. So I hope that at the end of this module, you will be able to do an equally good job at expressing complex patterns in LTL.